In this video we're going to have a look in more detail at electrophilic substitution mechanisms. This is the mechanism that you'll encounter when looking at electrophiles reacting with benzene or other benzene molecules. If we have a recap of our AS mechanisms and look at cyclohexene, we have a localized pi bond. That means that there's a high electron density, and so when the bromine molecule gets near to the alkene, the bromine molecule polarizes. An electron pair from the pi bond can attack the bromine molecule, and that breaks the bromine-bromine bond. We end up with a carbocation intermediate and a bromine ion. The alone pair on the bromine ion can then form a bond between the carbon and the bromine, and this gives us our product. Now, as can be seen here, we no longer have the double bonds, and we have added bromine across the double bond. This isn't an addition reaction, this is electrophilic addition. If we look at benzene now though, the 6 pi electrons are now spread over all 6 carbons of the ring. This means there's much lower electron density in a benzene ring than you'd find in a localized pi bond. This means that it cannot polarize a bromine-bromine bond, and so we don't get a reaction if we mix bromine with benzene. And so we need a much stronger electrophile if we're going to react with benzene. So I'm going to use E+, so it's got a positive charge, it's a much stronger electrophile. And this can accept a pair of electrons from the pi system of the benzene ring, breaking that pi system. And so we form an intermediate that looks a little bit like this. Now you can see I've put a U shape to show the pi system going over 5 of the carbon atoms, but not the top one, and a positive charge in the middle. And it's now, that top carbon atom has 2 groups attached to it, the H and the E. So now the electrons from the HC bond break down to go back into the pi system, reforming our benzene ring, leaving a substituted ring and H+. Now you can see this substitution because we swapped the H for an E. Okay, so in recap, we've got electrophilic substitution mechanisms happen on benzene rings rather than electrophilic addition.